Good afternoon. All right, well, let's go ahead and start with the roll. See who's here. All right. All right, Jimmy.
Here.
Joanna.
Here.
Ashley.
Here.
Marissa.
Here.
Jerica. Courtney.
Here.
Jada.
Here.
Matthew. Weston.
Here.
Chan.
Here.
Kelly.
Here.
Okay. Seth. Here. Trey.
Here.
Kayla.
Here.
Tobias.
Here.
Nathan. And Rebecca.
Here.
Okay, so absent we have Nathan, Matthew, and Caroline. All right, so next we're remember we're going to do our midterm tomorrow and Wednesday. So let's see. So am I even on? Okay, there we go. Sorry. So let's see. Teresa, are you there in Hopi?
Yes, I am.
Okay, so we're all set with computers for tomorrow?
Yes, we will be.
All right, awesome. Thank you so much. And it's good to know who the face is back there. So thank you.
Same here.
All right. And Shauna in Winslow?
Yes, we have laptops.
Okay, so we're all good to go for tomorrow and Wednesday?
Yes.
Thank you so much.
Welcome.
All right, and Tyson and Shanto?
He left for a while.
Okay. Would you ask him to make sure that you'll have a laptop? Well, you have a laptop now, don't you?
Yeah.
Okay, so we're not worried then, as far as the midterm then, I guess. So that'll be tomorrow and Wednesday. Okay. So just remind him that we're doing that. Okay. And then Crystal in St. John's.
Yeah, we got him.
We're good. All right.
Yep.
Yes.
Yeah, you're an old pro, Weston. I know you know what to do. Okay, and then in WMC, let's see. Let's see. So Ashley, you're the only one there today, right?
Yeah, the rest are in choir.
Yeah. So do you remember the room I told you to go to?
It's L something.
All right, LC 124. I'm pretty sure that's it. Miss Heaster will be there tomorrow and Wednesday to help proctor the midterm. Okay.
Sounds good.
All right, and so so then you'll take it in that computer lab, and then Jeannie and Mogion, we're all good to go. Mogion, I know.
We're good.
All right. So did you decide if you were going to have them take it in the room there or in the library?
Probably the library because we're about to roast in here, and we have we can spread out more in there. I can put them each at one table. Is that if that's all right with you?
If you want to see how they do under stressful conditions, just stick them in there. Bring a heater in there. Just really try to See how
That
they
counts
get under
as cruel and unusual punishment. I think
Hey,
that's
listen.
Especially for me.
Oh, well, no, you sit in the library and watch them. But no, you guys will do fine. Listen, if you can succeed in sports, you can succeed in math. All right, it's just the same thing. So anyway, no, it's weird how we all have our own comfort zone. And for say for me, taking a midterm in math, that was always easy. But doing this play that I'm in, it's so out of my comfort zone. I would much rather address a room full of PhDs about teaching math than what I'm doing. But sometimes you got to get out of your comfort zone to grow, right? So anyway. So, does anyone have any? So when you walk in tomorrow, right when the class is supposed to start at 2:50. So what I'm going to do is have the midterm open tomorrow and Wednesday right at 2:50, and I'll probably you'll have at least 50 minutes. I might give you an extra 5 or 10 minutes just in case. I know some of you have to catch a bus or something. So, I had 2 50-minute periods with my other class, and they didn't have any problem at all as far as finishing because I just put 10 questions each day. Okay, so I don't think that's going to be an issue. But if there is a problem, like let's say your internet goes down or whatever, then just have your lab aide email me, or if it's something that I can immediately fix, then probably my cell phone is the best way to reach me, because no matter where I'm at, I take my cell phone with me. Okay? But if there was some weird thing, but just know that if there's ever any kind of technical glitch, that I will work with you. Okay? We'll figure it out. Don't panic. Don't think I'm going to fail this class because the school's internet went down. Okay? It's not going to be like that. All right? I'm not anticipating any problems, but I'm not going to come on. There's not going to be a recording tomorrow. Okay? So when class starts at 2:50, you just log on and just start the midterm. Okay? We all good? It is open book, open note, and I emailed all the lab aides to let them know that. But don't feel like you have to look up everything, because you want to be able to finish the 10 questions. Okay? So that will be tomorrow and Wednesday, so then I won't see you again till Thursday. All right? But you're going to text me, call me, whatever, if there's any problems. All right, does anyone have any questions, comments, concerns about any of that? Okay. All right, well, the next thing that I would like to do is just do a quick run through of just some of the basic ideas that we've had in the first 3 chapters. I think these are questions that students have asked me in the past to review. And so then when I go over that, then if you have any questions, we'll do that. And then we're going to start in on chapter 4. So that material, the new material we covered today, will not be on the midterm. All right. Okay. So does anyone know what this slide is teaching?
The sandwich rule?
Nice. Good job. So this is the sandwich theorem. Okay, let me just go ahead and type that up. All right. Sandwich. Whoop. Okay, so the sandwich theorem says it's like remember, so suppose we want to find the limit of just some awful function. Or maybe we don't even know the function at all. It just says find the limit of f of x. Okay? And all we know is that this awful function lives between these two functions. So it would be like the green one. And it lives between the red one and the black one. Okay? Actually, let's... Okay? So it's between these two. All right? So then if we can figure out what the limit of the outer two functions are, and they happen to be the same, then it sandwiches the answer in the middle. So if we can figure out, let's say, if I want the limit of 1 minus x, and I know that's less than or equal to star, which is less than or equal to 1 plus x, and I want the limit of this function as x approaches 0. Well, so as x approaches 0, then I get 1 minus 0, which is 1. Here I get 1 plus 0, which is 1. And so since this function lives between the other two, then its limit as x approaches 0 must also be 1. And so that's how the sandwich theorem works. So therefore, so I'll put the 3 dots, meaning therefore, the limit as x approaches 0 of star has to be 1. Okay, now, also, if you don't, everything that we go through here today on this little review, I'm going to post it right after class, okay? So I'll put it up on the Moodle. So you can download it, print it, look at it, whatever, okay? All right, so any other questions about the sandwich theorem? All right, next, displacement. The question is, what is displacement? Well, the symbol that we used for displacement was delta S, the change in position, okay? Change in position. Okay, so if I'm given a function, a position function, and I want to know what's the displacement after 3 seconds, then I would do the s of 3 minus the s of 0. Okay, so it's kind of like the difference in the y's, the change in y's, the change in displacement. The displacement is the change in position. All right, any questions on that? All right, next, acceleration. The acceleration is the derivative of the velocity or the second derivative of the position. So if you're given the position, you take the second derivative to get acceleration. So suppose I'm given, this is my position function, and I want the acceleration function. Well, my first derivative is not the acceleration, but the velocity. And then I take the derivative of that to get the acceleration. Now here, since the acceleration is a constant, that means it doesn't matter what t is, the acceleration is always -2. And so at 5 seconds, the acceleration would be -2. At 1 second, the acceleration would be -2 because it's constant. All right, any questions on acceleration? All right, next, the chain rule. All right, so the chain rule is where you multiply by the derivative of the variable. So when we first started taking the derivative of like x squared, we could have used the chain rule and said the derivative of x squared is 2x dx dx. But just for simplicity's sake, we didn't worry about dx dx when we're first learning to take derivatives because that's always equal to 1. Okay? But in general, when you take the derivative of a different variable, and you say, okay, the derivative of star squared would be 2 star d star dx, where star could be anything. Or if we wanted the derivative of 3x plus 5 squared, then the derivative is 2 times 3x plus 5 to the first, and then you multiply. So this is like your d star. You're the derivative of 3x plus 5. So then you take the derivative of 3x plus 5, and that's 3. Now, if you have a coefficient in front and a number here multiplying the back, usually you multiply those together. Also, since there's no exponent on the set of parentheses, we can distribute. But if there is an exponent, like if this is to the second or third or fourth power or whatever, then you cannot distribute. But in this case, we can. And so you'd see the answer look like that. All right. Any questions on the chain rule? All right. Now, this is like the, this is kind of like the double chain rule. Okay. Because now, whenever I have a trig function where the exponent is here in the middle, like how it's normally written, I actually rewrite it this way, because I find it easier to take the derivative. Okay, so now I'll bring the 2 in front. So it's 2 times all of this. So you don't change that, and then you multiply by the derivative of the inside part. Well, so then you have the derivative of sine is cosine of 3x squared plus 5. And then you use the chain rule again and multiply by the derivative of the inside part of that, which is 6x. And so now you bring the 6x times the 2, and that's about it. Okay. So I'm going to label this the double chain rule, because we're going to use it twice, use the chain rule twice. All right. Any questions on that one? Or any other questions about the chain rule? All right. So does anyone remember what this is we're doing? What is this formula for here?
Linearization.
Linearization. That's right. Okay. So again, the concept behind linearization is that if you zoom in enough, then the derivative, the line here, is going to act the same way as this crazy function does. Okay? And so this is the formula right here, and it's similar to the point slope formula. So, for example, if this is my function and I want the linearization at x equals 0, well, the first thing I could do is figure out what the y value is by just plugging in 0 for x. 0 minus 0 plus 0 minus 1. So negative 1. Because I am going to need the y value at some point. I'm also going to need the derivative at x equals 0. So I take the derivative, 3x squared minus 8x plus 1. And now I plug in 0 for that, and I get 1. So then the linearization is, so using this formula up here, L of x equals, okay, the y value, which is negative 1, plus the derivative at the point times x minus the x value, which is 0. And so then if I simplify that, I get L of x equals negative 1 plus x. All right. Any questions on that or about linearization? All right. Next, the formal definition of the limits. Okay. So this was the delta epsilon that used the formal definition. Now, the only questions I'm going to ask you on this are very general, but the idea is that when we're trying to find a limit and we want to be within a certain epsilon, then our x that we choose to plug in, we can figure out what the delta is. So sort of how far off we can be here to be within however close you need us to be there. So, like, if I want to take the limit as x approaches 3 of this function, 2/3 x plus 1. So as x approaches 3, then you say, well, how far do I need to be within this y value of 3? And so that's the idea, the delta epsilon idea. Any questions on that?
Can you scroll down?
Sure. This is just showing that when you're calculating the limits, really what you do first is you're just substituting in. So you just substitute in 3, 2/3 times 3 plus 1. So that's how we get the 3. It's the limit. So in practice, that's what we're doing. But in the formal definition, we're saying that if we can't plug in the 3, we can get as close to 3 as we want. Okay? Any other questions on that one? All right, so this was the formula that we used. We said that this absolute value of f of x minus L is less than delta. Implies that 0 is less or equal to x minus x of 0 is less than epsilon. Okay, So let me show you where everything goes if you're doing this formal definition. So here, the f of x, that's the function. So this goes here. The limit, that's your L, so that goes here. Okay? So so let's say we're trying to find delta. Okay? So then you say the limit minus, or excuse me, the function minus the limit in absolute value is less than delta if 0 is less than or equal to, okay, x minus x of 0. So x minus, okay, what x is approaching the 2, that's the x of 0, is less than epsilon. Okay, so then to solve this, you're trying to find some since you're not told a number for delta or epsilon, then you're just going to find a relationship. Like delta is 3 epsilon, or delta is epsilon divided by 2, or something like that. We're not going to get a number here because we're not told what delta or epsilon is. Okay? So to simplify this, if we simplify inside here, okay, and then factor out a 2, or excuse me, a 3, then see we're going to get the absolute value of x minus 2 is less than delta divided by 3. Well, that matches this one exactly now. So that means you can substitute delta divided by 3 is equal to epsilon. So depending on what it is you're trying to find, you could say delta divided by 3 is epsilon if it's solved for epsilon, or if you want to solve that for delta, delta would be 3 epsilon. All right, any questions? All right. All right, that's just another example. Let's see, is there anything? Let's see. Okay, in this one, we actually don't know L. So what do we do to find L? Well, that's just finding the limit of the function. So if I know the function and I know what x is approaching, if x is approaching 3, then I can just plug in and figure out what L is. Just simplifying that. So, and in this case, I know I'm given epsilon. So now I can actually find a value for delta. Okay. So let's go through it again. So here we have, so 0 is less than x minus what x is approaching. So, well, okay. So x is approaching 3 is less than delta. Implies that the function minus the limit, so 3 minus 2x minus negative 3, is less than epsilon. So I'm wanting to simplify this again. So let's say I have 3 plus 3. It's going to be 6. And then here I can factor out a negative 2. Oh, It's funny. Okay, so here, instead of factoring out, I could actually solve this inequality for x. Let's see, let me just check something out here. Okay. So if to solve this inequality, you take the opposite of this number is less than this is less than 0.02, and then solve for x in the middle. So add 6, divide by -2, and remember when you reverse the inequality, to reverse the inequality. So then here, if 3.01 is greater than x is greater than 2.99, see, our target was 3. How far off? Remember, you take the smallest one. Well, in this case, the difference in both directions is 0.01. So an alternative way to do this is if I factor out like I did on the last problem, and I factor out a -2, oh, I see why. Well, so then if I, oh, okay. Yeah, I see why I didn't do that on this one. Because, see, this would lead you to believe that delta could be negative. Delta and epsilon can never be negative. If you're going to say how far should you be from a number, you can't say a negative. So that's why we're using the absolute values. But see here, if I had x minus 3 and divide each side by -2, I would get greater than -0.01. So then since these match, see, you might say delta is -0.01, but it's actually the absolute value. So that's why you would still get delta is equal to 0.01. Even though it looks like it would be negative there, delta can never be negative because you're saying how close you need to be. So it's actually going to be the absolute value. Okay. So the absolute value of -0.01. So that's just another way to do it. Okay. All right, any questions on that?
What happened to the 3 in your second example?
Why is it what?
What happened to the 3? The absolute value of x minus 3? What happened to the 3?
Because when you set it up, it's x minus what x is approaching here. So if x sub 0 or c or whatever the variable they're using, if that is approaching 3, then that's what you use. It's always x minus whatever that number is. Okay. Good question. Any other questions? All right. Okay, next, this question says, how do you find a limit from a table? All right. Now, remember, the easiest way is to just try to plug in the number. But to find a limit from a table, okay, first you put the function in for y equals, okay? So here's your function, whatever it is, okay? You put it in into the y equals. All right, next, you do the table setup and you change it from auto to ask for the independent variable. Okay, next, you press table and then you type in the values approaching the number from both sides. So like if you're approaching 2, then you plug in 1.9, 1.99, 1.999, 2.1, 2.01, 2.001, and so on. Okay, the limit is what y approaches. The y value that it approaches. So here you can see the y value coming from each direction would be 5. And so that would be the answer. So if you ever get stuck on a limit problem, I would recommend you do that. And if you type it in the calculator correctly, you can get the answer every time. All right? Any questions on that? Okay. Okay, next, what is the definition of the derivative? So the definition of the derivative is where you use this limit. The limit as h approaches 0 of f of x plus h minus f of x all over h. It's that same thing every time. Okay? So if you're asked to find the derivative using the definition, then the first thing you do is, okay, so here's your function. So your f of x you'll be given. So now you have to find the f of x plus h. So in place of x, you're going to plug in x plus h. So that would be x plus h squared plus 2 times x plus h minus 3. All right, so now plugging in into this definition. So the limit as h approaches 0. So the f of x plus h. So I go ahead and multiply this out. And I get x squared plus 2xh plus h squared plus, distribute this, 2x plus 2h minus 3. So all that's the f of x plus h minus the original f of x all over h. And so now everything in the second set of parentheses should cancel. So x squared minus x squared. 2x minus 2x. Negative 3 plus 3. So it all cancels. So you're left with 2xh plus h squared plus 2h. Everything else canceled. And so you know you're doing it right when at this point you can factor out an h and cancel. And now finally you can plug in 0 for h. Because up till this point you couldn't, because that would give you 0 in the denominator. And so now you plug in 0 for h. And so we just have 2x plus 2 is our final answer. All right. Any questions on the definition of the derivative? All right. Next, finding tangents to curves. Okay. So first of all, the slope of the tangent is the derivative. So if we're given a function and we take the derivative, then that's the slope of the tangent at any point. Okay. Then if we're given a specific x value, we plug in 0 for x, for example, and we get the slope of the tangent at that point. Then if we want the equation of the tangent, then we put it in the point slope formula. So y minus the y coordinate equals m times x minus the x coordinate. And then we simplify that, and that would be the equation of the tangent, or that would be, the equation of the tangent line at that point. So the derivative gives you the slope of the tangent anywhere. And then at that point, we can figure out the tangent and then the equation of the tangent. All right. Any questions on that? All right, next, limits at infinity. So when you're doing a limit at infinity, that's when you compare the powers. Okay? So if, in other words, you find the horizontal asymptote like you did in pre-cal. So you compare the powers. So like here, the highest power in the numerator is 1/2. The highest power in the denominator is 1. So if the denominator wins, then what does that mean? If the denominator wins, then what's the horizontal asymptote or the limit? When you compare the powers, when you're doing a limit at infinity, if the power in the denominator is bigger, then the limit is always y equals 0. If they tie, then the limit is y equals a over b, where a and b are the leading coefficients. If the numerator wins, then there is no horizontal asymptote. The answer is either going to be infinity or negative infinity. And this is one where you would have an oblique asymptote if the power is bigger in the numerator. Let's see if I've got one of those. Yep, there we go. Well, so next I was going to show how to find an oblique asymptote. But does anyone else, I mean, do you have a burning question? Anybody? Something that you want to know? I mean, these are all questions other students have had. All right, let's do an oblique asymptote. Okay, so to find the oblique asymptote, again, if you're asked to find this limit, okay, actually let's write it how the question would look on a calculus on the midterm. It would say find the limit as x approaches infinity. And so then you would compare the powers. since the numerator wins, then it doesn't have a horizontal asymptote, it has an oblique asymptote. So to find out what that oblique asymptote is, you do polynomial division. So you put the numerator is the dividend, x cubed plus 2x squared minus 4x plus 10. The denominator is the divisor, x minus 4. And so then you look at just the leading terms and you say, well, what times x is x cubed? And it's x squared. And so then you multiply through and then subtract, change the signs, boom, boom. This cancels, this goes to 6x squared. Bring down the next term. So then you look at the leading terms again and say, what times x is 6x squared? And the answer is 6x. You multiply through and get 6x squared minus 24x. Change the signs, boom, boom. This cancels. This comes to 20x. You bring down the next term, the plus 10. Look at the leading terms again. What times x is 20x? The answer is 20. So you multiply through 20x minus 80. Change the signs, boom, boom. This cancels, this goes to 90. But you really don't care at this point because that's just the remainder. So the answer, the quotient, is the oblique asymptote. So y equals x squared plus 6x plus 20. Okay. And so as x approaches infinity, this value is going to go to infinity. So the answer to the limit, if it says what's the limit, the answer is infinity. If it says what's the oblique asymptote, then it's this, y equals x squared plus 6x plus 20, and you just ignore the remainder. All right, anybody need more time on that screen? Okay. All right, marginal. The question is, what does marginal mean when you're talking about economics? Marginal means take the derivative. So marginal revenue is like R prime. So if you're given the revenue, to find what is the marginal revenue just means take the derivative. So the derivative of R of x would be 200 minus 4x. So then the marginal revenue for 5 cogs or whatever it is, now you plug in 5 for x. And so there the marginal revenue would be 180. So the marginal revenue of 5 means take the derivative, then plug in. All right, well, that's it for the review. That's it for our time. I didn't think we'd take all that time, but hey, that's all right. It's all good. Okay, so again, be ready as soon as you start class. Tomorrow, you just log on to the computer and just go. And then you'll have an hour each day to do those 10 questions. Okay? You can't help one another. You can't even talk unless it's to your lab instructor. But you can use your book and your notes. Okay?